Okay, so apparently it stopped recording, so let me go over these. They are already written, so I'm trying to cover up answers here. Okay, so in order to find a prime here, you're going to take x, you're going to make it negative. So this x was 0, making it negative is still going to be 0. Making 2 negative is going to become negative 2, and making c negative is going to become negative 0, which is just 0. Okay. When we get onto the y's are going to stay the same. So you're still going to have, y was 0, so it stays 0. Y was 0, it stays 0. Y was 3, it's going to stay 3. So we have our a prime, our b prime, our c prime as points. When we go to plot these, a prime didn't move, so it's right here at the same point as a. B did move, so b prime is now over here. And c actually didn't move either, so c and c prime are the same point as well. So you can see that that triangle is just a reflection. Okay, so now for the trickiest transformation here. All right, so we write down what A, B, and C all are. And then you'll notice that when we're looking for our new x, it's negative 2 times what the y was. So what I'm going to put in this spot is negative 2 times the y was 0. So negative 2 times 0 is 0. Negative 2 times this y was 0, so negative 2 times 0 is 0. Negative 2 times the y was 3, so negative 6 is going to be in the x spot. Okay. Then, to find the y value, you're going to take the original x and you're going to make it negative. So our original x was 0, make it the opposite, 0. Our original x was 2, make it the opposite, negative 2. Our original x was 0, make it the opposite, 0. So there we have our 3 points. When you plot this one, you'll notice that this one is the only transformation that we did, other than these two. This is the only one, though, that is not an isometry or a rigid motion, because our triangle changes. It's no longer the same size. It stretches in one direction. Okay? So this is a non-rigid motion or non-rigid transformation, or it's not an isometry. Any of those sentences are all the exact same because those words are used interchangeably. I want to take a minute and show you on your homework what I'm looking for, because it is important that you show your work in order to earn full credit. So when you go to do this assignment, you need to start by labeling A, B, and C values on your graph. It doesn't matter where A is, which one's B, which one's C, but you need to tell me where is A. So where is this point at? Then tell me where B is at and where C is at, just like we did on the notes. And then you have to tell me, okay, now using my rule, where does A prime move? So you have to figure that out. Okay, same is going to go for this entire front side. You have to show me all of this work in order to earn your credit here on this front page. On the back page, it asks you if each of these undergo a rigid motion or an isometry. So remember, a rigid motion or an isometry means it has to stay the same shape or size. So you have to say yes or no and then explain it. So answer with yes because, no because. Down here, it says that the triangle XYZ is mapped to X prime, Y prime, Z prime. Okay, so maybe if you want to draw that in, just an example. This says what's the image of X, the segment XY. Okay, so if it was a segment originally, probably moved to a segment, if it's going from a triangle to a triangle. What's the transformation of the point Z? This is a point, so what is the transformation? Remember that means it's going through the transformation of point Z. Where does point Z end up? What's the pre-image, so the original, if you're looking at angle Y prime? Can you conclude, now remember, this does not have a line over top of it, so that means the distance between X and Y is the same as the distance between X prime, Y prime. Why or why not? Okay. And then point M is the midpoint of segment AB after a rigid motion. Can you conclude that M prime is the midpoint of A prime, B prime? Why or why not?